Hey guys, so we've been talking about reviewing combining like terms and remembering that you can't combine two terms unless their variables and their exponents are exactly the same. Today we're going to extend that learning and talk about using area and perimeter as a way to get practice for combining like terms. So this lesson is going to review area and perimeter and how we find area and perimeter, mostly of rectangles. I might throw a triangle in there. And then we're also going to talk about still reviewing combining like terms, because that's a huge standard that you're going to see on the map test. So perimeter. Perimeter is the distance around a shape. Go ahead and write this down. To find the perimeter, you add up all the sides. Remember, perimeter is adding, and you have to add up every single side. Even if the measurements for that side aren't listed, you are going to be expected to figure out what they are and add them up anyway. You can remember the word, you remember that perimeter is adding because it's a long word and it's a longer math problem than like finding the area. So when you find the perimeter, you're going to go, I'm going to use the variable s to represent side. You do side plus side plus side plus side. This would be the perimeter of a square. That is going to be a longer math problem than finding the area, which is side times side. Okay? So the perimeter is longer, the math problem is longer, the word is longer. All right, so let's practice a little bit with perimeter. So remember when I said that sometimes you're not going to see all the measurements for the side. So you need to pay really, really, really close attention to what they're asking you to do, and then you need to use your brain to figure out which sides, what the measurements for the missing sides are. So here we obviously know, 3x plus 2, and then perimeter is adding, so we do plus x plus 6. Now there's two ways we can do this. I'm going to do it the long way because again we're practicing perimeter. This is a rectangle, so I know that this side and this side are equal. So I've already added this side, and I'm going to go ahead and trace what I've added so that I know I'm getting all sides. So I've added this side and I've added this side. Now I need to add the bottom side. Because I know that this is a rectangle and the top and the bottom are equal, I know that this is also 3x plus 2. So I'm going to add that on there. And then I also know that this side, so I've added this side is equal to this side. So this side is also x plus 6 because it's a rectangle. They have two equal sides. I'm going to add that to my end of my problem. You guys see what I mean when I say that perimeter is a longer math problem? Like when you write it all out, it's a longer math problem than just finding the area. So now we're going to solve this. We're going to combine like terms to figure out what our perimeter would be. Note that when we have variables, and we're talking area and perimeter, we are not going to be able to get a number unless they tell you what that variable represents. So our final answer is not going to be a number, it's going to have variables in it. Before I do this, I'm going to separate. Sometimes it helps to visually separate all of the terms in your problem. So I'm going to draw little lines here. And then we can start combining like terms. So you cannot combine everything unless the variable and the exponent are the same. The coefficient, the number that's in front of that variable, doesn't matter. That's what you're combining. But your variable has to be exactly the same. So let's go with blue. All right, so I'm going to circle all of my terms that have an x as the variable. So I've got 3x. I've got a positive x. I've got another 3x, and I've got another positive x. Now I believe Mr. Cook told you that if a variable is standing by itself, you can imagine a 1 being in front of this. So we're going to imagine a 1 right here. All right, so I have 3 plus 1 plus 3 plus 1. That would be 8. 3 plus 1 is 4, plus 3 is 7, plus 1 is 8. So the first part of my answer is going to be 8x. And then I'm going to figure out what my individual numbers are. Let's see here. All right, so now I have terms. I have a term without a variable. So I have positive 2, positive 6, another positive 2, and another positive 6. 2 plus 6 is 8, plus 2 is 10, plus 6 is 16. So my final perimeter for this shape is 8x plus 16. Okay, and that's my answer. Unless they give me what variable x is, unless they tell me what x stands for, that's the answer. That's as far as I can get. I can't combine an 8x and a 16 because there's no variable on the end of this 16. All right, you guys try number 2 on your own. Okay, so here's where I said that I might throw in a shape that is not a rectangle. So we're going to do this in red. All right, so perimeter, no matter the shape, you still add up all the sides. So we are adding 2/3 x and we're going to add, because it's perimeter, we're going to add this side plus 1/2 x plus 1. So this whole piece was that second side. This was the first side. And then we're going to add the third side. Plus 5/3 x. Oops. That's a minus 10. Let's see here. Minus 10. All right, that might come back to bite me a little bit. We'll see. Okay, so I'm going to go ahead and separate all the terms in this problem. So I have 2/3 x, positive 1/2 x, positive 1, positive 5/3 x, and that's a negative 10 right here. That's a negative 10. All right, so let's combine all my terms that have an x as the variable, because that's the first thing that I get to. So that would be 2/3 x, 1/2 x, and 5/3 x. Now, just like we learned about during our do now yesterday when we compared the fractions to put them in order, we can't add these fractions unless we have a common denominator. So common denominator means that the number on the bottom is the same for all of these. Our lowest common denominator for 3 and 2 and 3 is going to be 6. So I'm going to make equivalent fractions. So I'm going to kind of do this over here, and then I'm going to rewrite my problem. So 2/3 is equal to 4/6. And I know that because 3 times 2 equals 6, 2 times 2 equals 4. So this is going to be actually all right, ignore that. So actually, this is going to be 4/6 x. And then let's go ahead and change this one here. 1/2 x into 6. 1/2 is equal to 2 times 3 is 6. 1 times 3 is 3. So this is 4/6 x plus 1/2 or plus 3/6 x. And now we're changing 5/3 x into 6. So let's go over here. 5/3 is equal to, again, to get from 3 to 6, we multiply times 2. 5 times 2 is 10. All right, so this is a positive 10/6 x. Once we have the denominators all the same, then we just add the numerators and stick them over our original denominator. So to combine these terms, where x is my variable, I'm going to add up, I'm going to change the denominator to 6, and then I'm going to add up all the numerators. 4 plus 3 is 7, 7 plus 10 is 17. So I end up with 17/6 times x as my final product. When I combine those terms, that's what I get. It doesn't say to change improper fractions into mixed numbers, so I'm just going to leave this as 17/6. And then my other terms that are left are my solo numbers. So I have a +1, and if you remember, this is a -10. So it's right here. It's -10. So I have 1 positive, I have 10 negatives. Couple different ways you can do that. You think about a number line, you can think about minuses and pluses. So I have 1 positive and 10 negatives. This positive and this negative cancel out. I'm left with 1, 2, 3, 4, that's a negative, 5, 6, 7, 8, 9 negatives. So my final answer is 17/6 minus 9. Nope, my final answer is 17/6x minus 9. All right, try number 4 on your own. Now let's talk about area. So the area is the space inside of a shape. You find the area of a rectangle by multiplying the length times the width, or the base times the height, if that's what you prefer. Basically, there are two sides that make a 90-degree angle. Multiply times multiply. You remember the area of a rectangle? Area is multiplying because it's a shorter word and a shorter math problem. So perimeter is a long word, a long math problem. Area is a shorter word and a shorter math problem. It's just multiply times multiply. All right, so here we go. This is going to be, should be a little bit simpler than what we just did. So we are going to multiply the length times the width. And in area, we only need to do those two sides, the area of a rectangle. We only need to do those sides. We don't need to worry about what the measurements of these sides are. So I'm going to do 4 times 5x plus 3. Now this should look very, 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 very familiar to you. When we do this, when we have a number times expression inside of parentheses, we have to multiply that 4 times everything in the parentheses. So we end up doing 4 times 5 is 20, and we got to tack that variable on there. 20x plus 4 times 3 is 12. I'm sure Mr. Cook went over this with you, but when you multiply, it's totally fine to multiply a number that doesn't have a variable next to it times a number that does have a variable next to it, as long as you take that variable with you. So 4 times 5x, we can totally do that. That's fine. It's 20x as long as you bring that variable down. And then you can still multiply that single number times a single number, as long as you bring the plus sign, or if it's a minus sign, bring it down. So this is the area. This is the area of this rectangle. 20x plus 12. They don't tell us what x stands for, so we can't fully solve it yet. So it's just an expression, it's not an equation. Remember, an equation has an equal sign. All right, do number 2 and number 3 on your own. I saved number 4 for the video because it's a little bit more challenging. Okay, and here's why I saved it for you. Because we've got fractions. So we've been dealing with adding fractions, and when you add or subtract fractions, you need to change the denominator so that you have a common denominator. Your denominator is the same for everything that you're adding or subtracting. Here, though, we're just going to multiply. We're going to do 3/4 for our one side times, and then this entire expression is the measurement of our second side. So we can say this is our length, this is our width. So this entire expression is our measurement. 8 minus 1/5 x. So, just like we did before, I have to multiply 3/4 times everything in this expression, and I need to make sure I take that variable down with me, and I take this minus sign down with me. This is not as challenging as it seems, because multiplying fractions, all you do is change any whole number you've got and put it into a fraction. And to change a whole number into a fraction, you just stick it over 1, because 8 divided by 1 is 1. 8 divided by 1 is 8. 8 first is 8. Okay? And then you just multiply straight across with your fraction. So I'm doing 3/4 times 8. 8 times 3 is 24. 1 times 4 is 4. Some of you guys should have some red lights flashing in your head right now because every fraction is just a division problem. 24 divided by 4 gives me an even number. I can simplify this really easily and really quickly, so I'm going to. If you leave it as 24/4, I would think that it would be fine unless it says to simplify your fractions completely. So I'm going to go ahead and simplify because 24 divided by 4 is 6. So when I do 3/4 times 8, I get 6. So I'm going to bring this down because I multiply this times this. I end up with 6. And then I have to multiply minus 1/5 x. So I also have to multiply 3/4 times 1/5. Again, that seems challenging, but it's not, because when you multiply fractions, you just go straight across. So I have 3/4 times 1/5. All right, and then all I do is 3 times 1 is 3. 4 times 5 is 20. 3 and 20 don't have a common factor, so 3/20 is as simplified as this fraction is going to get. I need to make sure that I bring down this minus sign into my final answer. And then I have 3/20. Ooh, not like that. Oof. I am messing up a lot in this video. 3/20 x. And that's my answer. Make sure you bring down that variable. So this is telling me that I'm multiplying x times 3/20, whatever the variable x is. If x is 4, I would do 4 times 3/20, and then I would do 6 minus that number. Okay, but we don't know what x stands for yet. So we're just going to say it's 3/20 times x. So the area of this shape is 6 minus 3/20 x. And that's how you do it. All right, guys. I will be back on Monday, unless you're a Webster and you're watching this on Monday, in which case, hey, Webster, Casey, make sure you're taking notes. You guys have a great couple of days. Have a great weekend. I will see you on Monday.